Welcome back to our lecture series on control systems. So this is the 13th lecture. In this lecture we are discussing about second order system. So in last class we were discussing about first order system. In that we derived the standard equation for the transfer function of a first order system. Standard equation means we can compare any first order system with the standard model, and from that, if it is 1 plus st, 1 by 1 plus st is the standard form, and you are getting some equation like 1 by s plus 2, you can compare these. Ts is equal to 2. So what will be the value of t and what is s, how fast the system is, such things you can compare. So for analyzing any given example, whether it is a second order system or first order system, whatever, we should have a standard model for that system. Then only we can compare each term to the corresponding term in the standard form, and then we can do further analysis. So in the previous classes also we did a lot of problems by using some second order system. Like we derived the mathematical modeling of a spring mass system. I hope you all remember that class, a spring mass damper system, and we obtained the input was some force and the output was some displacement. So we derived the entire input output relations into a differential first order I hope it was a second order differential equation, into a second order differential equation. So how you can identify a second order differential equation easily? Its highest term will be d square some variable by dt square. For example, d square phi by dt square, like that, or d square I by dt square. And then we converted that differential equation into a Laplace domain equation. How we can convert that into a Laplace domain equation? For each term we are having some standard results from differential term. D square phi by dt square is equal to s square into some term. Such some standard results are we are having that, and we converted the entire differential equation into a equation in s domain, and then we took all the initial conditions as 0, and finally we got output by input relation, y of s by u of s, and that was the transfer function. If that transfer function is some second order transfer function, its denominator will be having a higher power s square. If it is a third order differential transfer function, its highest term will be 1 by s cube. So for determining the degree, we have to check the denominator of transfer function. For determining the order, we have to check the denominator of transfer function. If the highest degree of s term in the denominator is 2, then that is a second order system. Please clear. If c of s by r of s or transfer function is 1 by s square plus 5s plus 6, I am taking some arbitrary example, 1 by s square plus 5s plus 6. What is the highest s term? S square. So you check the power or degree of highest s term in the denominator. If that degree is 2, it is a second order differential equation. Correspondingly, I can say go back to the previous step. What was there in previous stage? It was not in s domain, it was in time domain. It was some differential equation. If you are having some doubts on this, please check our mathematical modeling class. I think it was lesson number 4 or 5. Then you will get the clear concept about this. So if here in the s domain, the transfer function, the denominator is having highest term s square, definitely that differential equation in the previous step should be having a d square term. D square some variable by dt square. D square some variable by dt square. That will be there in the differential equation. So you are having two methods. If you are having transfer function with u, please check the degree of highest term in the denominator. If you are having the differential equation of particular physical model, then check the order of differential equation. Both the things will help you to determine the degree or order of a transfer function or order of a system. So now I am going to standardize a second order system. Actually 1 by s square plus 5s plus 6 is also a second order system. But all the second order system will not be this much simple. This is a simple system. Why? Why I am saying this is a simple system? Any guess? Because here roots are easily determinable. Just fractionalize the denominator. Denominator is s square plus 5s plus 6. So characteristic equation is s square plus 5s plus 6 is equal to 0. That is the characteristic equation. Then please fractionalize that equation. S square plus 5s plus 6 is equal to 0. That is equal to s plus 2 into s plus 3 is equal to 0. Then s is equal to minus 2 and minus 3. So here roots of the denominator are s is equal to minus 2 and minus 3. There was one other name for the roots of denominator. In term of control system, roots of denominator are known as poles. Roots of numerator are known as zeros. Here numerator, there is no roots are there in the numerator because no s term is there in the numerator. Numerator is just 1. So you found the roots of denominator. So poles are minus 2 and minus 3. These are real numbers. If the poles are real numbers, we can easily fractionalize like this. But it will not be always such real numbers. Imaginary numbers may also come. In that case, fractionalization is not this much easy. If you are having a calculator, you can easily find the solution by selecting the degree is equal to 2 and you have to input this equation. Then they will give the roots. So our aim is we should have a standard reference model for second order differential equation, like we already done in first order control system. So that model should be capable for representing all the type of poles. It may be real poles, it may be imaginary poles, whatever. So I am going to derive such a standard representation for second order system, standard second order system. So any second order system can be represented like this. That is the concept. Any second order system can be represented like this. Here now I am presenting only forward path gain. The closed loop transfer function we have to derive. In this figure, forward path gain is given omega n square by s into s plus 2 eta omega n. So what is damping ratio and what is omega n? These are the two important things. So before going to that, we have to go for 2 or 3 steps further. Then it will be it will be very easy to understand what is the concept of eta and what is the concept of omega n. Anyhow, omega n is undamped natural frequency of oscillation. So you have to take something into your brain that second order system is normally having a tendency to oscillate. If you are not providing any remedies to stop the oscillation, what happens? Your system never goes to a final steady state value. It will always oscillate around the final value. If this is the final value, say it is 1 in the graph, it is a line of 1. Your output will be always like a sine wave oscillating around the value of final value. It will never stops at the final value. That is the general behavior of a second order system if we are not providing any damping. So what is damping? Damping, physical meaning of damping is friction. If friction is not there, system will never stop. If you are running on a surface without having any friction, it is very difficult to stop at some point. It will be continue in a sliding motion like that. A friction should be there to attain stability, unless it will never become stable. It is oscillating like this. Okay, so now we are coming into more details. Anyhow, please keep these 2 points. A second order system, if you are not providing any techniques or any external methods to reduce the oscillations by using damping ratio eta, then the system will always oscillate around the final value. For example, you are giving a unit step input. Unit step magnitude is 1. Output should attains unity. For a control system, if you are giving reference as input as unit step, here the U of S as unit step, the system, if the system is stable system, its output should be fed back to the input and this error will be given to the system, and finally after some time Y of S should become 1. It may be 0 initially, but after some time it should touch the final value 1, as we discussed in the last class. But if it is a second order system and you are not providing any mechanism to provide damping or to reduce that oscillation, or you are not providing any friction element, then what happens? Output, if this is the desired output value, our output will never, it starts from 0 and it will go away the 1 and it will come down to the 0, again go to the magnitude like 2 in the top notch, again goes to the 0, like that. It is a oscillating like a sine wave. It will never stops at the final value. For example, I will say some interesting physical example for this system. In our laboratories, we can see many meters, many analog meters like ammeter, voltmeter. Say, if you are measuring a 2 amperes current, its pointer should move from 0 to 2 like this. But is it instantaneously possible? Will it move at very high speed to 2 and will stop at sharply at 2? No, it's not possible. It will go to some value like 2.2 or 2.3 and it will come back to 1.8, 2.2, 1.9, 2.1, 1.95, 2.5, like that. Finally, it will come to some 2. So, actually it was a oscillating response, but the oscillation is controlled like this. Oscillation was like this. Its magnitude is reducing. Finally, it will attains the input value. It will touches the desired output value provided at the input. It will indicates 2 ampere current. So, it is not a undamped response. We are providing some damping to reduce the oscillation. So, what may be the damping in that system? Yeah, I think everybody completed measurements. There should be some elements like spring or some damping, mass damper, some air damping, some eddy current damping. Such system should be there in order to increase the friction or in order to limit the oscillations. Otherwise, if there is nothing like a spring damping or eddy current damping, nothing is there, what happens? It will go to 2, but it never stops at 2. It will be always oscillating at same magnitude. That is example of undamped system. That is an example for undamped system. If system is damped, the magnitude of oscillation will reduce and finally come to a exact value. So I will repeat this example in the all coming classifications. At that time you will get more idea about that. So if roots are imaginary, the response oscillates around final value with omega n frequency. But the thing is that roots are imaginary. In our previous example, it was 1 by s square plus 5s plus 6. So roots where s is equal to minus 2 and minus 3, the roots are real. That system will not give any oscillating response. So second order system may be having oscillating response and fully damped unoscillating response may also come. But such all systems can be represented in this form. It will become clear more in this class or the upcoming class how all the systems can be represented by using this standard form. Don't get confused. So eta is the damping or friction provided to stabilize it. Now, what was the g of s? Omega n squared by s into s plus 2 eta omega ns was the omega n was the g of s. Now we are going to find c of s by r of s, or output by input, or y of s by u of s. That is nothing but g of s by 1 plus g of s h of s. So just open the bracket, omega n squared by s squared plus 2 eta omega ns, that is the g of s, divided by 1 plus omega n squared by s squared plus 2 eta omega ns. Now what happened? We have to take the LCM, so this term will move towards this side. That will become s squared plus 2 eta omega ns plus omega n square in the numerator, and this denominator will get cancelled with this denominator. So totally what will be the thing remaining after the cancellation? That is omega n square by s square plus 2 eta omega ns plus omega n square. This is the standard representation of a transfer function, closed loop transfer function of second order system. Previously it was open loop transfer function. Now we converted that to a closed loop transfer function. Y of s by u of s is equal to omega n square divided by s square plus 2 eta omega ns plus omega n square. Okay. Now y of s u of s is equal to that equation. Now with the characteristic equation, that is denominator is equal to 0, that is equal to s square plus 2 eta omega ns plus omega n square is equal to 0. This is a quadratic equation. For finding the solution, we are having a standard equation minus b plus or minus b square minus 4ac by 2a. So in this equation, what is a, what is b, what is c? A is the coefficient of s square term, that is 1. B is coefficient of s term, that is 2 eta omega n. And c is the constant term omega n square. That is the coefficient of s raised to 0th term. We can say like that also. It is a constant term omega n square. So a, b, c are clear. Okay. Now I am substituting the things in the that equation. So I know there will be at least two roots because highest term is s square. So roots are s1 and s2. Two roots will be there. That will be equal to minus b, minus 2 eta omega n plus or minus b square 2 eta omega n square minus 4 into a is 1, into c omega n square by 2a. 2a means 2 itself because a is equal to 1. Now that is equal to minus 2 eta omega n plus plus or minus 2 eta omega n square. Okay, that is same equation, minus 4 omega n square by 2. In next step I am dividing these 2 and this first term, so that will become minus eta omega n plus or minus square root of, just open the bracket, or I am squaring each term, 4 omega n square eta square minus 4 omega n square by 2. In next step minus eta omega n plus or minus, I am taking 4 omega n square to outside of the root, then it will become 2 omega n into root eta square minus 1. Is it clear? By 2. In next step I am dividing that all terms with this 2, then it will become omega n, that is this 2 get cancelled with this 2, so it will become omega n, and then I am taking a minus negative sign outside, then it will become 1 minus eta square. And as the negative is inside the root, it will be root minus 1. Root minus 1 is nothing but j. Root of minus 1 is j. So in the next equation it will become minus eta omega 1 plus or minus j omega n root 1 minus eta square. So S1, S2 are minus eta omega n plus or minus j omega n root 1 minus eta square. And I am as this is somewhat bigger expression, I am simplifying it by using some new terms. Minus eta omega n is replaced as minus alpha, and j omega n root 1 minus eta square is simplified as j into omega d. So omega d, damped frequency omega d, damped frequency omega d is nothing but omega n into root 1 minus eta square. And alpha, damping factor, please write, I don't know whether it is there in the slide or not. No, I think it was, there is a missing of these two terms. So alpha is damping factor, and eta was damping ratio, and alpha is damping factor. Here it is. Eta is damping ratio and alpha is damping factor. Damping factor is nothing but eta into omega n. And omega d is damped frequency, that is omega n into root 1 minus eta square, where omega n was undamped frequency. Okay. Now you are having the S1 and S2, both these roots are having some real part and imaginary part. And one more interesting thing, these two roots are not just two imaginary roots, they are conjugates, complex conjugates, because minus eta plus j omega d and minus alpha minus j omega d, these two are conjugates. So real part is minus alpha. Imaginary part for the first pole is plus j omega d, minus alpha plus j omega d. This is the first pole, S1. And second pole, real part is minus alpha, imaginary part is minus j omega d. So this is the pole. So S1 and S2 are marked. And these two poles are conjugates or complex conjugates. Now I have marked some important things are there. Now it is a system with real and imaginary parts, like some example of resistance and reactance. You have to find the magnitude and the angle. For finding magnitude, you have to take square root of both real part and imaginary part. So magnitude is square root of minus alpha square plus omega d square. For finding magnitude, these minus will not make any sense, because please check, this magnitude will be equal to this magnitude. Both magnitudes are same, whether it was in the second quadrant or it was in the third quadrant, its magnitude will be same. So for finding magnitude, don't get confused about by taking plus or minus here. It is just the alpha square plus omega d square in a common square root, that is the magnitude. Square root of alpha square plus omega d square, that is the magnitude. Okay. Now please find the angle of the poles. Angle here I am marked in the figure. This is the angle phi. So if that is the angle phi, what will be the cos phi? Cos phi is nothing but adjacent side by hypotenuse. So that is equal to alpha by total magnitude. Alpha by total magnitude. Here it is, alpha by magnitude. Magnitude is here. Here you already got the expression for magnitude. So magnitude is equal to, I am substituting here alpha. Instead of alpha I am giving eta omega n. So alpha square is replaced by eta square omega n square. And instead of omega d I am giving omega n root 1 minus eta square. If you are solving this like the by opening the brackets, it will become like this. Here this term and this term will get cancelled. So finally magnitude will be omega n. Finally magnitude will be omega n. So what will be the cos phi? Substitute 2 in 1. Cos phi is alpha by omega n. Alpha is nothing but eta omega n. Alpha is damping factor and eta is damping ratio. Alpha is nothing but eta omega n. So eta omega n by omega n and omega n get cancels and finally it will become eta. So cos phi is equal to eta, then phi is equal to cos inverse eta. This is very important result, because the angle of that complex pole, the angle created by the complex pole depends on damping factor. So damping factor is an important thing that determines stability also, because if the angle changes, the pole may come to the imaginary axis, the pole may go towards the right side, the pole may come to the real axis. All these things can happen. So eta is very important on stability. So when eta varies, whether stability increase or decrease, that also we have to check. That will be there in the next lecture. At that time, please correlate these things. And this video lecture and the upcoming video lecture are really that much correlated. So I recommend you to give some time or take some time for watching both these videos together. Then it will give good results. So eta is damping ratio and eta may varies from 0 to 1. That is an important thing. The range of eta is 0 to 1. So phi is equal to cos inverse eta. So eta is equal to 0 means phi is equal to 90 degree. And eta is equal to 1 means phi is equal to 0 degree. Here, please take. Eta is equal to 90 means phi is equal to, yes, eta is equal to 90 means phi is equal to 1. Sorry, I made some confusion. Please remember this figure. Eta is equal to 0 means phi is equal to 90. Eta is equal to 0 means phi is equal to 90. So when eta 0, this pole moves towards this axis. So phi will become 90 if the pole is on the imaginary axis. Eta is equal to 0 means pole will be there on the imaginary axis. Pole is there on the imaginary axis means it is a marginally stable system. If pole is exactly on the imaginary axis, it is a marginally stable system. If pole is left side, stable. Pole is right side, unstable. Marginally stable system means it will be oscillating like that. So eta is equal to 0, that is also a chance. Such a system is known as undamped system. And if eta is equal to phi, then what happened? Sorry, eta is equal to 1, then phi is equal to 0. Phi is equal to 0 means this pole will move towards real axis. Not only that pole, both S1 and S2 will move towards the real axis. And the system will be really stable because both poles are at the left side. But for that case, eta should be 1. Eta should be 1 means eta is maximum. Eta's range is 0 to 1. So you are damping the system. Damping means you are giving some friction to the system. Then definitely that system will become stable. That is the concept I want to convey. Anyhow, don't get confused. You have to remember up to this only. Up to this only. All the other conclusions I will derive in the coming classes. Don't get confused how I can remember all those things. Don't think so. Okay. Now I am explaining some more concepts, that is undamped system. Anyhow, second order system is having a huge number of classifications: undamped, underdamped, overdamped, critically damped. All these things are done based on value of eta. How much friction you are providing to stabilize the system. If you are not providing any stabilization, the system will be oscillating. It will never reach the final value. That is the thing you have to remember. It will oscillate always. So first of all, we are learning undamped system. Undamped system means eta is equal to 0. So eta is equal to 0. From the last discussion, we know that eta is equal to 0 means phi, here please check. Eta is equal to 0 means phi is equal to cos inverse of eta. Phi is equal to 90 degree. Phi is equal to 90 degree means both the poles will come. This is the pole S1. For making this angle 90, this pole will move towards this imaginary axis, and this pole will be moving towards this imaginary axis. Then this angle will become 90. So when eta is equal to 0, roots are imaginary and are placed, both the roots are placed on imaginary axis. No real part will be there. Okay, that was from the graph, and from the equation also we can derive that S1 and S2 is equal to minus eta omega n plus or minus j omega n root 1 minus eta square. When eta is equal to 0, this term alpha, total alpha term is 0 plus j omega n into root of 1. So S1 and S2 is 0 plus or minus j omega n. So roots are plus j omega n and minus j omega n. So here no real term parts are there with these complex roots, only imaginary parts are there. So both the roots are placed on imaginary axis, plus j omega and minus j omega. And please check the angle from the x-axis, real axis, it is 90 degree. For both the poles, angle is 90 degree. So what is the issue? If the poles are exactly on imaginary axis, such a system is known as marginally stable system. So if you are giving some step input, its output is somewhat bounded. We know these things are discussed in lab, some class before, I think it was on the 9th lecture or 8th lecture. We discussed the stability from location of poles. At that class we know that if it is a system with poles on the imaginary axis, it may be giving bounded output for bounded input, but for some particular a single bounded input, it will give unbounded output. That was the concept. Anyhow, if you are giving a step input, it will give some bounded output. Sine wave is bounded because we know what is the lower magnitude and what is the higher magnitude. So it is a bounded output. But we know it will never reach the final steady state value. It will be always going like a sine wave because eta is equal to 0, damping is equal to 0. So if you are giving a step input like this, what happened at the output? The output always oscillates around the final value 1. It will never stay. It will never touches or never attain the final value 1. Like this. If the input is unit step, output will be starts from 0. Response will start from 0, go to some higher value like 2, come back to 0, like that. It will be oscillating. As the poles are non-repeating and placed on imaginary axis, this system is marginally stable. It is an important thing. Even though the poles are there on the imaginary axis, there is chance for instability also. If there are 4 poles, where 2 poles are placed on plus 2j and 2 poles are placed on minus 2j, is it marginally stable? No, because poles are repeating on some same point. Even though all the poles are on the imaginary axis also, then also the system will be unstable. But here we are having only 2 poles and both the poles are placed on imaginary axis and no poles are repeating. So system is marginally stable. Now I am having only one doubt. How I got this response? For finding the response, we are having some mathematical method. We are having y of s by u of s, some transfer function, and then you have to find y of s by cross multiplying the input u of s, and then you have to find y of t. That is the response. Here I didn't conducted any such analysis and I am directly drawing the response. So I know this is the response. How you know? how you came to know this is the response of such a system. Then for your knowledge, I am deriving only for undamped system. This derivation is there for all the other classifications also, but I am deriving only for undamped system. The remaining thing you have to work as some homework because it is somewhat lengthier. So let us derive the time response of second order system with undamped control system. We are not doing for other systems. For an undamped system, we are finding the time response by taking step input. If input changes, the response also changes. We are considering only step input. Response of undamped system for unit step input. Okay, so C of s by R of s, you know, omega n square by s square plus 2 eta omega ns plus omega n square. And here, eta, as it is undamped system, substitute eta is equal to 0. As it is undamped system, substitute eta is equal to 0. So when eta is equal to 0, this equation will become omega n square by this whole term will become 0. So omega n square by s square plus omega n square. Now, as it is a unit step input, r of t is equal to 1. Unit step, it's just like this. Output is 1 always. R of t is equal to 1. Sorry. R of t is equal to 1 and R of s, its Laplace domain expression for 1 is 1 by s. R of s is 1 by s. So C of s is nothing but plan transfer function into R of s. You have to cross multiply these things. So here this is the plan transfer function into R of s, that is nothing but 1 by s. Now I am going to do partial fraction. For that I am splitting the things. There is two terms in the denominator. One is s square plus omega n square and the other one is s. So I am splitting. I am splitting like a by s and b by s square plus omega n square. I am splitting into a by s plus b by s square plus omega n square. Now, a is obtained by cross multiplying all terms by the denominator of a. Here the denominator of a is s. So for finding a, you have to cross multiply all terms with that denominator s and then put s is equal to 0. In this term, denominator is equal to 0. So s is equal to 0. So you are cross multiplying all terms means this was the actual term and this was the left side term, so right side term. So you are cross multiplying both LHS and RHS with s. So this s and this s will get cancels, and here it was s into a by s, so it will become a, and this will become bs by s square plus omega n square. Is it clear? Did the multiplication on both sides. Definitely this b term will become 0. No need to calculate in any such partial fraction technique, simple partial fraction. No need to do for doing the calculation, because as s is here and you are going to put s some value, definitely this b term will get cancelled. And if you are going to find b, then that a term will get cancelled. You don't waste time on that. Anyhow, here put s is equal to 0. So this term will become 0 and a is equal to these s and these s will get cancelled. Omega n square by s square plus omega n square, and in that s is equal to 0. So a is equal to omega n square by omega n square. So a is equal to 1. Now for finding b from the first expression, please tell how we can find b. Take the denominator of b, s square plus omega n square, multiply on both LHS and RHS, and then put this denominator is equal to 0, s square plus omega n square is equal to 0, then s square is equal to minus omega n square, then s is equal to plus or minus omega n into j. Not plus or minus, s is equal to plus j omega n, because s square is equal to s square omega n square is equal to 0. S square is equal to minus omega n square. So s is equal to square root of minus 1, that is j, and square root of omega n square, that is omega n. So s is equal to j omega n. So do that analysis. Multiply s square plus omega n square on both sides. Then these s square omega n square and this s square omega n square will get cancels, and put s is equal to plus j omega n. When s is equal to j omega n, I already told you these don't do calculation. Definitely this term will get 0. So b is equal to omega n square by s, because these two terms will get cancels. These and these will get cancels. B is equal to omega n square by s. Put s is equal to j omega n